Thank you very much. All right. So I'd like to thank you all for attending my presentation today. As Simon said, my name is Matt Fisher. I'm a video playback engineer at Twitch. Today I'll be discussing the state of live video playback on what we refer to as the modern web. And I'll be using, obviously, Twitch as a use case. What you'll leave here with is a better understanding of how video works, live video works on the web, and some of the unique issues that we experience as engineers at Twitch with the type of ecosystem we've created. So as Simon, I'll elaborate on what Simon said, I'm originally from Toronto. I moved to San Francisco to work at Twitch just over a year ago. I was the 65th employee at Twitch, and we're over 200. We're around 220 now. So in a year and a half, we have grown at an enormous rate. And as I mentioned as well, I'm a video playback engineer. Oh, I hit too many keys. 1 second. I'm a video playback engineer, so I work in specifically making video playback on Twitch as good as it can be across multiple platforms. So I can kind of see the audience, but just a quick raise of hands. How many people know what Twitch is? How many people don't know what Twitch is? Okay, we got some people. I'll quickly cover this, but I won't spend too much time on it. Twitch, in essence, is a live streaming platform. We are the glue between broadcasters who want to broadcast themselves playing games and viewers who want to view them on many different platforms from anywhere around the world. We are now owned by Amazon as of August 2014. We were purchased for $1 billion, which is pretty exciting and really validating in terms of the new type of content we were creating, how we were doing it, and the type of people that wanted to back us. Twitch started in 2006 as a website called Justin TV, and after a couple of years, it was self-evident that gaming was the type of live streaming content that people were gravitating to the most. So in 2011, Twitch was born. The category of gaming was taken from Justin TV, and it created its own site. So the content on Twitch can either be viewed live or on demand. We pride ourselves on our live service. We allow our broadcasters to export their videos to other video-on-demand services like YouTube that focus more on VOD content than we do. That's not to say that we want to make our VOD product better, but primarily Twitch is a live streaming service. So I'll play this video quick and to help you get a little better understanding of the business. Can you guys hear this?
Twitch connects millions around the world by letting them broadcast, watch, and chat from everywhere they play. Live streaming helps communities grow around games and products, and Twitch sits proudly at the forefront of live gaming. In fact, since its founding in 2011, Twitch user engagement has already surpassed that of other entertainment platforms. More people are spending more time watching live streams on Twitch, and more viewers encourage more broadcasters, a number that tripled in 2013 alone. Broadcasters benefit from paid advertisements while contributing to our ecosystem of dynamic content, which in turn attracts more engaged viewers. Whether on a computer, mobile device, or streaming via console, people can watch and broadcast on Twitch from virtually anywhere. This accessibility plus ever-increasing engagement opens the door for uniquely impressive advertising formats and strategies. And because Twitch hosts the most highly skilled gamers on the planet, these ads can draw millions of interactions. Users can also immerse themselves in live global esports events, live industry events, and community-created live charity events. If it's a big deal, you'll find it on Twitch. And if you're not on Twitch, you're missing the opportunity to connect with consumers in the next generation of multimedia entertainment.
Okay, so what does this all boil down to? In essence, this is, I'll preface this with, I primarily focus on desktop usage of video playback on Twitch. That's not to say we work on platforms as well, but primarily my role is on desktop. So what this boils down to is an interface that looks like this. What you're seeing here is a screen capture I took a week or two ago of a Counter-Strike Go tournament that was taking place. You're watching a commentator's view, a spectator's view, per se. He is commentating the match that's going on. Everybody who's playing here are pro Counter-Strike players. They do this for a living. They get paid to do it, and some of them get paid very well. But if you look at the bottom, there's also 100,000 people watching this right now. And you can get a glimpse of that action in chat. In chat, you can see a lot of people saying the same things at once, because right now they're entering in a raffle that is being held by the tournament. People are entering to win things like keyboards and mice, and from sponsors that are putting on the tournament. You can also see that there's options to subscribe to this channel to get extra benefits as a viewer. Yeah. From a different perspective, there's also a more casual broadcaster on Twitch. So here's a really popular broadcaster on Twitch named Bacon Donut. He primarily plays Minecraft, and he has a fantastic following and community that he's built up around his broadcast. It's extremely casual. He plays Minecraft all day. He's a grown adult, and he has a blast doing it. So the type of conversations that they have in chat could range all the way from gaming to whatever. I think when I was taking this screen capture, they were talking about how you cannot get real milk, like unpasteurized milk anymore in stores. Like the conversation had seeped far away from gaming, but the community aspect was still there. Finally, I'll talk about quickly about Twitch Plays Pokemon, which is a phenomenon that happened to us in March 2014, where a random Australian programmer decided to take his Twitch stream, his favorite game, and introduce the chat aspect of Twitch, the fun aspects that Twitch chat brings with the broadcast, and integrate it into the gameplay. So you're watching hundreds of thousands of people playing the exact same game of Pokemon at the same time. What's astounding is that despite the chaotic nature of what you think would happen here, like the swarm mentality or hive mind actually beat the game, and they beat all of the Pokemons now. The developer would continue adding new features and making it better. You can see at the very top there's an anarchy and democracy mode. People would vote whether people's interactions would be averaged, then used, or would every action come out to an action in the game. So some really weird things happened, but a whole new idea was brought up around the idea of a whole bunch of people watching content from all over the place, but contributing to it as well. So in numbers, this is quite substantial. As of at the end of 2014, Twitch was averaging 16 billion minutes watched per month. That's over 30,000 years of video every month being consumed by our viewers. We would have over 100 million unique viewers per month. And our viewers are very, very interested in the content that we're putting on because they stay for an inordinate amount of time. Average play sessions could be over an hour and a half per user on average. For broadcasters, we have well over 1.5 million unique broadcasters per month. And that comes out to over 11 million total videos broadcasted per month. At the end of 2014, we were averaging 1 million concurrent peaks at any given point in the day. And that was at the end of 2014. Just recently in Poland, there was a CSGO tournament, and their single stream peaked at 1,012,745 viewers for one stream, which is pretty astounding, let alone the amount of people that were in the crowd, as you can see by this photo. So, getting a little bit more technical, Twitch in the last couple of years has tried to focus more on platform usage, that be broadcasting from platforms, as well as viewing from platforms. As I mentioned before, I primarily look at things from the desktop usage side, but because of the modern web and how web works in mobile and other platforms now, sometimes they can seep into one another. So right now, Twitch supports iOS, Android, Google Chromecast, NVIDIA Shield, both Xbox platforms, the PS4, and the Amazon Fire. You can even broadcast your gameplay from Xbox and PlayStation, which is built right in from the factory, which is really cool as well. So what this all meant was we needed to create an architecture at Twitch that would allow us to deliver that content to everybody. And what we were originally built on was an RTMP protocol, which was an Adobe spec that allowed audio and video to be sent into the Flash player to be played back extremely efficiently. It creates very low latency playback. You can almost be 1 second behind the broadcaster at times. It makes for a great viewing experience. However, there's some limitations to it as well, right? It's made to work in the Flash player, which, as we all know, doesn't really work well on platforms. It's a protocol that's been around for a while, so it's more proprietary than things that are out now. RTMP is delivered over its own port, which is unique to itself. It's unique to some server-side software as well. Twitch decided that at the time, the best move for us was moving into HLS, which is a segmented format of video delivery, which I'll discuss a little bit more in a second. HLS was a spec that was proposed and released by Apple, and it came with native support on iOS and OS X. Media streaming, the benefit of HLS is the idea of how content is broken down and delivered. In RTMP, as I mentioned, when you have static ports and unique ports, the flow of data is not over traditional methods. HLS delivers video over port 80, which is what all web content is delivered over. So in effect, our video sits on a web file host or a CDN the same way as any other content, like an image would. The way we manipulate that data is a little bit different, but the logic and how it's sent is the same, which is great for not only debugging, but understanding how the data actually gets around the world. So let me break this down a little bit so you understand the flow of what happens in this architecture. It all starts off with the broadcaster. You're sitting at home on your computer or your PlayStation or your Xbox, and you want to stream to Twitch. The initial step is really easy depending on what platform you're using. Desktop usage, I would say, is a little bit more complex than the console usage just because of the integration. But nevertheless, it's not very hard to start streaming on Twitch. What you do in the first step is effectively take snapshots of your screen or take the video of what's being piped to your monitor. You can modify it with overlays and such, but you're effectively taking that, encoding it real time, and sending it to us. You still encode that video in RTMP, the old protocol that we worked in. But because it's in RTMP, it makes things really fast and efficient for this one-way communication to us. So step number one, you send your video to us, and it's ingested in our ingest network. We have 18 nodes around the world that you can connect to. You can choose whatever point of presence is closest to you and use that ingest node to send your video to. What does ingest do? It's basically what it sounds like. It takes in content and then distributes it to the next step. And the next step in our flow is transmux. Transmux is the process of changing a video format or audio format into something else. So as I mentioned, we bring in video in RTMP, but we don't use RTMP out. So we need to take that data and convert it into something else, into HLS. The transmux step then would move into a transcode step. Transcoding, and I'll explain transcoding a little bit more, but transcoding is the idea of taking one format of video and segmenting it into multiple qualities. So anybody who's used YouTube is familiar with this. When you go to YouTube and you don't have the best connection, you can change your quality. Sometimes qualities are just too high for your computer to play back, like 4K or 2K video, so you can select that quality. We are taking live video in at real time and possibly transcoding it into multiple qualities real time as we're sending it out. Transcodes on Twitch are given to our partners, and our partner program reaches out to people that are becoming more popular on Twitch and effectively moving broadcasting into their daily life or their profession. Transcoding is very expensive, as you can imagine, taking content and outputting multiple forms of that content at once in real time. So that's why we can't give transcodes to everybody, because Twitch has over 10 to 20,000 live channels at any given point. We have about 6,000 to 8,000 partners. They're not all streaming at once, but you can get an idea of percentages of transcode. The next step is segmentation. As I mentioned, HLS is a segmented protocol. So what we then do is take that video that we've either transmuxed and transcode, we take that video and we break it into chunks. Now the chunks are determined by timeline. And right now on Twitch, on average, when you're watching content, you're watching it in 4-second chunks. At the moment, we're playing with different chunk sizes and trying to lower chunk sizes to, say, 2 seconds, because you can imagine the benefit of downloading 2-second chunks would be faster, so you'd be closer to the broadcaster in terms of latency, an issue I'll get into very shortly. But 2-second segments also mean more requests to the edge or the CDN. If you're only requesting once every 4 seconds, then the latency for you to the CDN could potentially sum up to be a lower amount than doing twice the amount of requests. I'm going to move this. So all of this happens at once. It's a very, very quick process. As much as I could sit here and technically explain it for days, it's very complex, but it's very quick, and it happens at once. The final step in our Twitch backend is content and distribution for our data. So we need to replicate our data and distribute it around the entire world. We have CDN. Twitch has its own CDN, and we operate our own CDN. So we have points of presence around the world, around where our main customer bases are, and we're expanding those points of presence almost on a weekly basis. But we have to send all of this content that we've now manipulated out to all of our edge nodes. Because when you want to watch it, you want to be watching from the closest edge node. Latency is a very important factor to Twitch because at the time all of this is happening, there's people in chat talking to, what are you guys, okay. There's people in chat talking to the broadcaster at the very same time, and we don't want things to become out of sync too much. You can imagine that if a broadcaster is broadcasting live video and you say hi, and they say hi 2 minutes later, the conversation doesn't really take shape. So to have things as close as possible is very important to us. Now, I'm on the video team. We have chat teams at Twitch, and we work in different pipelines, but we work very close together to make sure this is seamless as possible. But as one can imagine, chat moves as far as bandwidth and bytes moving across the network. Chat is way quicker than video. Video is very cumbersome. So at the end of the day, chat is always going to be ahead of video. We're not going to add a delay onto chat to fix this issue. Our job as video playback engineers is to figure out how to get these two processes as close together as possible. So the other part of this is, how do we play this video back? This is a huge portion of my job. To conserve time, because again, this is another topic I could sit and talk about for days, let's just quickly cover the most modern browsers right now. And by modern, we'll talk these 4 browsers as well as their latest and greatest versions. So when it comes to HLS, surprisingly enough, it's not very well supported. To answer anybody's questions is probably what they're thinking right now is, why would Twitch choose HLS if it's not very well supported? HLS is very well supported on platforms, not so much desktop usage. And HLS, at the time of our decision to switch, was the best avenue to go down. An alternate avenue to go down would be using MPEG-, or media source extensions, or encrypted media extensions. MPEG- is kind of like the new player on the block. And it really boils down to its similarities to HLS, but its differences are in its openness. MPEG- is an open standard. It's an open standard that isn't fully finished yet, but it's a global standard that's being accepted by everybody, not controlled by a specific entity. HLS is created and owned by Apple, and they do with it what they want, which both of them have advantages and disadvantages. The major advantage to MPEG-Dash using media source extensions is the support, and the support is coming. The support isn't fully here yet, and it's about convincing all of these parties that this is probably the way that we should go. To break it down, MPEG-Dash is supported in Firefox right now, but because it's in early testing, it's only supported for YouTube. So, and we know it's coming, we know they're testing it, and we want to be a part of it, but it's about understanding the technology now and being ready for it when everybody can use it. It's supported in Chrome, both on mobile and desktop, and what's even crazier, in my mind, is that it's supported in Safari in the latest version of Yosemite. IE supports it as well. IE 11 on anything over Windows 8 supports it, which is fantastic. So you can kind of see that as far as general support, MPEG-Dash seems like the logical way to go, especially when you look at something like the final alternatives. Things like smooth streaming, RTMP, which we've already kind of talked about, or HDS. Just for some context, smooth streaming is like Microsoft's protocol that's built into IIS media servers. And HDS is HTTP dynamic streaming, which is kind of like the next iteration of RTMP that's similar to HLS, but still requires the Flash player to work in. So these aren't natively supported on any of these browsers. They require third-party extensions or plugins. So what does this mean? It means that Twitch uses Flash, and it's the one major project that I'm working on now to get rid of Flash on Twitch. But as much as we want to get rid of it, there is always going to be pros and cons. So we'll start off with the cons, because that's the easiest thing to do. The major con of using Flash on Twitch is HLS is not supported in Flash. So the bulk of my time and other engineers in video playback's time is working on solutions to this. We take HLS in segments, and in the client side, in your Flash player, we transcode that into FLV, which sounds crazy. And a lot of people that have used Twitch probably have no idea that this happens. But we can't natively play HLS back in the player until we convert it into a format that Flash player likes. To do this, we have to write C++, compile it into Flash, and then create our Flash player. Seems very convoluted, but it works, and it works pretty damn well. The amount of time it takes your client side to do this operation isn't very long, so you don't incur tons of latency, but you incur overhead on your CPU. So this means when you want to go do other things while you're watching Twitch, which is very common, especially with people with multiple monitors, you're going to really feel that hit. Twitch is going to start sucking up a lot of your CPU, and that's generally just inherent in the way that the Flash player runtime is working. So that's a huge negative for us. But there's always a win on this side, and surprisingly enough, it's ad sales. It's something that, you know, it's very important to Twitch, but it's not as exciting from a technical perspective. So let me just explain this really quickly, in that if we were to move to a full HTML5 solution, ad providers would not be near as happy, because what they deliver right now, and I'm sure what you've seen on many platforms, is a more interactive ad experience. People that make ads like to put their own tracking systems in them, like to put interactivity in them, nice videos, motion graphics. All of these things are very easy to accomplish in a compiled container like a Swift, but much harder to replicate in an open container like an HTML5 video or just a flat video file. So for us, ad integration in HTML5 is only going to be valid when we can emulate what we do right now with Flash. Now, I don't think we're ever going to get that far, so convincing ad providers that the methodology that they're using right now may not be perfect it may be in order. So, as I mentioned, this is a huge portion of my job, but the next step right now is moving out of this realm. We want to move away from Flash, and I think that's completely understandable from anybody's perspective. So, after looking at that last graph, the question is, are media source extensions the way to go for Flash? There's other things I didn't mention in that graph of protocols like WebRTC. These are technologies that we're using and testing, but don't really prove themselves to be adequate for what Twitch uses in its video infrastructure. For us, MSE might be the golden ticket. Media source extensions, because of their openness and their standardization, their acceptance by multiple browser creators, might be the best solution for us moving forward. And not just us, but a lot of video creators and content providers on the internet. So I say this because, first off, two big players in the market are already using MSE. YouTube uses MSE and MPEG-Dash. Over the last couple of months, they've primarily been serving more MPEG-Dash content than any other format. Because of how big YouTube is, they can toy with their backend and output multiple formats and try things because of how expensive it is. They can facilitate that with their infrastructure a little bit better. So there's been a tipping point over like the last 4 years where YouTube's been pushing slowly into this and getting support by specific browsers. As I mentioned, Firefox exclusively supports MSE testing just for YouTube. If you go look at the source codes, it's hilarious. It's like, only let this happen for star.youtube.com. But you know it's coming, which is great. And YouTube and the guys at Google have been working really hard to make sure that a protocol like this is the future. And as I mentioned, the browser support aspect is very important. Players like Apple starting to support MSE, IE with an extremely well-standardized browser is doing really exciting things for the future, not only JavaScript, but media source extensions as well. So the real answer is, I don't really know if this is the future. I hope it's the future. We're putting a lot of effort in at Twitch to build our playback around MSE. From what we've seen so far, we're really excited. The cost savings really come in that overhead. How much CPU you need to dedicate just to watch live video content. And when we start using things like media source extensions, that number drops dramatically. So that gives an overview of that issue. I want to explain a couple other issues before my time finishes. One is a really unique issue that comes with live video playback when we couple with chat, and I kind of touched on this earlier. But engineers at Twitch, we refer to it as hand wave latency. A lot of engineers actually hate this term because they don't think it sounds technical enough. But people actually understand what you're talking about, which is great. So hand wave latency, in a nutshell, is the time it takes for me as a broadcaster sitting in my computer to wave my hand in front of the camera that's filming me, and it's the time it takes for me to wave my hand for you to see that wave on your computer as a viewer. Now, you can think when we go through that entire pipeline, that's going to incur time. And as I mentioned, the decoupling of chat and video is a very important thing we want to avoid. So where does all this time come from in the latency? We can break it down like this, and I talk about this to emphasize how important latency is from the playback perspective. The broadcaster, when they're creating video and sending it into Twitch, the latency from their computer to our ingest server is less than a second on average. It's very, very minimal. Our service to transcode and do all that, grind the gears and get the video ready for the endpoint, on average takes about 5 seconds, which is a fair amount of time. We can send all that data to our CDN around the world in around 1 second on average. But then when it comes to playback, we have to do some really unique things with buffering and incur latency that generally we don't want, but to create a better quality of service for you as a viewer. As I mentioned, HLS is segmented. Things are in chunks, so we're watching 2-second or 4-second chunks of video. Our initial buffer at Twitch is 2 segments. We're playing with this, and this number could change. But right now, we're creating an initial buffer of 2 segments, which on a 4-second segment stream, that's 8 seconds of initial latency. So right when you start your stream and it starts playing, you're already X amount, what I just referred to in the last slide of all that timing, plus the initial buffer. So this could mean you're around 10 to 20 seconds behind the broadcaster. And then depending on how good your internet connection is, how close you are to our points of presence on our CDN, what your ISP is like, how good your Wi-Fi is, we might have to create more of a buffer so you don't buffer. We will go ahead and start allocating more chunks from the HLS stack and putting them into the buffer locally so that when your internet or when your capability to download goes a little bit below what it needs to, you don't stop playback. Because when you stop playback on a live service, something really weird happens. And this is another thing that we refer to internally as a unique issue. We call it time travel latency. Time travel latency is really unique in that on a standard VOD service, when you buffer, you just continue watching where you left off. That's fine, and that's all fine. That's what you'd expect. If you're watching a live broadcast and you're already 15 seconds behind that broadcaster, and you hit a buffer event where you need to allocate more data because you have nothing to play back right now, and say you take 2 seconds to buffer, we start you back where you left off. Now, this is a choice we make at Twitch on the video team. We have the choice of starting you as close to live as possible after you buffer, but there's a major issue with that. With gaming, and specifically, say, an esport, there could be a huge tournament on. And say it's the last moment of the tournament, and you get a buffer event. And then all of a sudden, you skip to after where all that action happened. And you would just sit there, you would go nuts, right? That's not a viewing experience that people want. So we start you off where you left off. But now that means you've incurred more latency from the broadcaster and fallen further out of sync with the context of chat. So for our viewers that don't really use chat, and we got a ton of them, there's people that are very active in chat all the time, and there's people that just sit back and watch the show. For people that are sitting back and watching the show, that's okay. These things happen. But for people that are using chat, it's very, very disconcerting. You're taken out of the context of the situation. You could be typing things in chat that happened a minute ago, and everybody else in chat kind of gives you the weird eye, right? So it's a very interesting issue. These all stem from the fact that, as I mentioned, we couple chat with video. And live video, in comparison to traditional methods like cable TV, never had this system coupled with it. You could go on Twitter and complain about TV hosts or things like that, but the two systems are so far apart that they never really, there's never any real relation made between the two. So these are some unique things that come inherently with video playback and working at Twitch. So to wrap things up, in conclusion, the best way I can always put it is live video over the web just really isn't easy. When you compare it to VOD services, live has completely different, it's a very different technical beast. Current browser support, as always, is always a big issue for engineers working in the space. However, there's a total light at the end of the tunnel, in my opinion, and we're getting very close to seeing it, which is great, and it's going to be beneficial for not only companies like Twitch, but other video companies as well. And finally, the move out of Flash Player. It seems funny that we're still using Flash Player, and we work on such cutting-edge technology on every other aspect, and Flash Player seems so archaic from a lot of people's perspective, but it's still extremely beneficial to us. As far as retaining ownership over our content, as far as ad integration, tracking integration, there's a lot of this we can emulate on different formats right now, but that just isn't as universally accepted as a Flash Player. And finally, the whole issue of latency and how unique it is in terms of traditional methods of measuring latency. I have to mention that, as I said at the start of the presentation, Twitch is growing like crazy. We're always looking for new talented people to come join us. If you're interested, not only in the video aspect, but any other aspect, feel free to either contact me or hit up jobs.twitch.tv. In September, we're having our very first Twitch conference, which is very exciting. It's going to be extremely large. I'm really excited to see how many people show up, both broadcasters and viewers, and creating even more tighter communities between the two. We're going to be focusing a lot on broadcaster education, and hopefully we'll have a lot of new exciting things coming up on twitchcon.com very soon. Tickets are already for sale, so if you're interested in that, you can check that out. Yeah, and I think we got about 10 minutes for questions if anybody has any. Perfect. Can you bring up the house lights? Because I can't see anything. Awesome. Go ahead. Sure. Sure. So your first question of if it's different, from an employee's perspective, from my perspective, no. Amazon is very well known for letting its subsidiaries stand alone and work as they were. I still have the same CEO. My structure is still the same. We operate the same, which is great from my perspective. As far as utilizing infrastructure, Twitch's infrastructure is very unique for what we do. Amazon's web structure and AWS works very good for web services. Might not necessarily mean it works as a proper CDN for our sake, but that doesn't mean that we venture into things outside of video. There's other web services that we definitely leverage Amazon Web Services over. Specifically on video, that's not necessarily the case, but we're always experimenting. This is still a relatively new thing for us as far as being owned by Amazon, and the amount of education and people we can bring in from Amazon to help us get to that next level. So it's not as apparent as I think some people would assume it would be. We still consider ourselves Twitch, not Amazon, right? So yeah, I hope that answers your question. Yep. Yep. So at Twitch, if you're getting transcodes on live, your VODs will be transcoded as well. You'll have multiple formats of VODs if you have multiple formats of live. And that's simply because we're creating them already. We could throw, 4/5 of them away and just keep one, but that doesn't make much sense when we already have the data. Twitch doesn't store video for indefinite amounts of time. That's a very expensive operation for us, and again, we focus primarily on live content. So our users are using live content far more than VOD content. That's not to say that if we make our VOD product better, more people would use it, but we focus very heavily on live. So if you're getting transcodes on live, you get them on VOD, and then eventually they'll disappear because they get deleted after a specific amount of time if you don't output them to, say, YouTube or something like that. But it's an expensive operation, not only like computationally to transcode everything, but the storage aspect then climbs as well. Granted, all the file sizes are different, but you can assume that it's going to be 3 times as much storage per video. So, yeah. Yep. Sure. Surprisingly enough, very common. If you look at other services similar to Twitch, actually a better answer to this is Twitch doesn't, the software you use to upload to Twitch from the desktop, we don't own. It's somebody else. There's multiple pieces of software out there that you can use to do this. We choose not to get into that space because there's tools out there that are really good. We can work with the developers of these tools and help them make them even better. But because there's pre-existing tools out there that work really great, we let them roll with it. And yes, they ingest our TMP. It works the best for keeping CPU usage low on the computer that's broadcasting, so the broadcaster can still use the computer and still be very quick. So it's not abstract from what is traditional. Yep. Sorry, can you say the first part of the question again? Right. No. If I'm understanding you correctly, you're referring to segmenting testing, like a release of a new player? Sure. Yes. Okay, so I think the easiest way to answer that is nothing really gets released on Twitch with a binary switch. We slowly saturate users with new features all the time. Whether we're testing or releasing, it's very, very dangerous to just flip a switch and say, everybody's using this now. If you have 1 million people on your site, you're going to get a lot of Twitter traffic, let's put it that way. So we slowly saturate, and we ramp up over time. We'll ramp down over time, depending on how we see things change. But I'd have to say, from my perspective on playback engineering, the coolest part about my job, and it's still to this day, is when I release code, I know it works or doesn't work within seconds. Because I have so much usage on it so quick that it's there. I know it's working or it's not. It's not like I need to sit there for 3 hours and make sure I can go have a good weekend. It's instantaneous because usage is so high, which is great. So you need to be very careful with that. And so every step that we take, generally from web, video, chat, it's always saturation, and it's generally a pretty slow approach. But yeah. Anybody else? I think we're out of time. Yeah, are we officially out of time? One more question. Why not? Your hand was already up. What's up? I'll speak to it from what I know best, and that's video. Chatbotting and things like that, the chat team would be able to elaborate much better than that, but much better than I could on an issue like that. As far as viewbotting goes, for those of you who aren't familiar, you're effectively paying, I'll do this really quick, you're effectively paying somebody to put views on your channel to up your popularity. It's an issue with Twitch because people are paying, it's like a pay-to-win strategy. It just doesn't work, and we definitely don't like that. So we put a lot of effort into it, to specifically combating how that data is logged. People can always try to spoof views. We put a lot of effort into not counting them. From a video playback side, the video team's got really good at this. And to put a rough figure on it, I'd say we kill over 80% of that data. And we're getting better at it every day. From any other perspective, I can't really speak to it too much. But I can tell you, as a whole, Twitch puts a lot of effort into combating that issue. And I think that's it for time. But thanks for everybody for showing up. I really appreciate it. Thank you.